Hello YouTube, this is Umozo3. So in the previous video, we went ahead and introduced the topic of functions, and we basically said that functions are modular pieces of code that basically extend the functionality, extend what our program is able to do, and we can basically call our functions within our main script, within our main code, in order to be able to reference those functions and figure out what functionality they actually provide to us. So then we saw an example of that yesterday. We can go ahead and come up with a function called apple, and it just accepts an input t. And then we could go ahead and say print of t integer division of 2. So now if you could go ahead and run it, right, you could go ahead and say apple of 9, right? And then if you go ahead and run this code, then you get the 4 there, right? And then it must have been, I must have been trying something else down here. So I'm just going to remove that. But that's why you get the 4 there, is because 9 is an input to the function, okay? And what we also said is that the order matters, okay? So one of the differences between Java and Python is that in Java, one of the things we did is we saw a class. So we have a class, basically a Java file, and we had our main sandbox method before some of our static methods. So it was actually calling on functions that were not defined until later in the program. With Python, you can't do that. So now if you go ahead and cut and paste this line that says apple of 9 to before apple of t is defined, then it goes ahead and says unresolved reference. Remember that the t here is just an arbitrary parameter name. So you actually could call this whatever you want. The function would basically be defined the exact same way if instead of t you called this w, but then you need to have consistency between what you're calling, the input here in this method header, and then what you go ahead and, refer to that variable throughout the function. So if you say, okay, this function is going to be apple of w, some arbitrary w, then you would say print of w over 2. So hopefully that makes sense. So that basically this function prints the integer division of the input it receives with 2, right? So 11 over 2 is 5. Right, and 1 over 2 is 0. So we talked about how basically this is how Java would divide two integers, as it would use Python's version of the integer division, this over. So anyway, I think that's enough on that. One of the things what we need to realize is that in Java, variable types are very sensitive and specific, right? So then if you look in the Java videos, basically what you could do is you could basically say f of int x. So you'd have to specify that the input is an integer, for example. And it's going to give us a Python suggestion. It's going to give us a PEP warning, right? It's going to say our line is a little bit too long. But like I said, you can choose whether or not you want to be bothered by that. So then if you go ahead and hover over it and then you press more actions, you can choose to go ahead and ignore errors like that. So anyway, but in Python, the distinction to be made is that W above is of arbitrary data type. Okay, so Python can work with inputs of arbitrary data types, and that seems to be the theme, right? You could have just said x equals 2, but in Java, you would have to say int x equals 2. So hopefully that's clear to you with what's going on here. But we would say, but the data type that you pass into a function must make sense within the context of how the function is defined. So let me tell you what I mean by that. This is saying print of something over 2. That means that basically the only valid data types that W can take are an int and a float. So what if if you go ahead and say apple of 15.2, then it would be able to go ahead and do that, right? It would not be able to run apple of 9 here because you went ahead and called the function before you defined it. But then if you go ahead and remove that code, right, it would be able to say 7.0, right? Because we basically learned about how this integer division works if you have a floating point number. So anyway, but then what happens if you go ahead and say apple of orange? So you're going to pass in this string orange. And then if you go ahead and run it, there's going to be a runtime error because it wouldn't make sense to do an operation like that. But we said, sometimes it's more flexible than that. So what if you had said apple of W would print W times 2? So here, basically, we said that if we have, print of A times B, basically, is the product of A times B if A and B are both ints or floats, right? And then it would be basically multiple concatenation if one of them is a string, And obviously, you would not be able to print the multiplication of two strings, right? So if you said orange, right? If you said orange times grapefruit, then that would not be a defined operation, right? So let's remove apple of, or actually, yeah, you would not be able to do that, right? So then we can just go ahead and test that out. We're not even calling the Apple function right now, but you can see that there would be an issue with that, right? But then, well, of course, we can concatenate, right? So that was the other type of operation that we said works for both, right? So if you said print of A plus B, this is the sum of A and B, right? This would be, I guess, the product of A and B. So this will be the sum of A and B if A and B are both ints or floats. But then we just said it's simple concatenation if one of them, if you have an int and a string, right? You couldn't multiply a string by a floating point number. So then anyway, we've already seen this before, right? But then if you said prints of 5 times grapefruit, it would say grapefruit, 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 grapefruit. It's kind of a tongue twister. So anyway, that's what we have going on here. But so then basically this function would work. Now what you could do is you could say apple of orange, right? So now you could pass in a string input and then it would know how to render that, right? So it would just say orange, orange. But then if you said apple of 16, then it would go ahead and parse 16 times 2. What if you had said string of 16? So now a string input is going to come in. So it's going to be interpreted as 1, 6. So instead of seeing 32, we're going to see 1, 6, 1, 6 because it's treated as a string that's being concatenated with itself. So hopefully that makes sense to you. And then we also talked about, basically, we talked about 2 more points. So 2 points from the last video, right? So a function can accept multiple inputs, but does not have to use all of those inputs. So let's come up with an example. So we can say basically define, let's go ahead and define sync of x, y, and z. Okay, and what this is going to do is it's going to print x plus 2 times y. Okay, and then you know the order of operations, right? So this would not be x plus 2 times y. It would be x plus 2 times y. So hopefully that makes sense to you. And here you can see there are actually 3 inputs into this function. And one of them isn't even being used. So I don't know how well you guys can see the color coding, but we talked about PyCharm, right? And we talked about how this integrated development does a little bit of color coding for us. So usually with function names, those are going to show up in yellow, right? Print statements will show up in purple. Numbers, at least integers, will show up in blue, right? But then if you're talking about a variable that gets used, then it's in white. If you're talking about a variable that's basically never gets used or sort of insignificant, it shows up in green, right? So then if you go ahead and say sync of 5 to 10, right, then it would go ahead and do 5 plus 2 times 2, right? Because the 10 doesn't actually end up making a difference. And then if you say sync of 5, 2, and 200, then you can see how basically that input doesn't actually affect the result of the function. So that's okay. But you can accept multiple inputs. Basically, the more general point is that you can accept multiple inputs, right? So then I'll just maybe just put those in square brackets because this is the main point that I'm trying to drive home. And then the other one is that a function can print something or it can return a value. So let me show you what I mean by that. What we said in the previous video is that, for example, if you're looking at this apple of w function, this function, if you call it, so if you write apple of something, it literally has the effect of printing w times 2. But we can also think of a function that would just return a value. So it wouldn't actually print anything, but it would, but the running the function would result in a number or a string or a list or a Boolean or something, for example. So let me give you an example. I've already written some functions down here. I was playing around with this earlier, but we want to go ahead and delete these 2 calls to the sync function. I'm going to show you what I mean. So what we're going to do is we're going to say get difference of x and y, okay? And you can actually, remember, you can call these inputs whatever you want, right? You can call these inputs whatever you want. You could have called them input 1 and input 2, but then you just have to have consistency between what you're referring to the variables as in the function header and what you're referring to the variables as within the definition of the function. And so what if you just say return input 1 minus input 2? Well, now it's not actually going to print anything if you call this function, but basically get difference doesn't print anything on its own, but you could set the result of the function equal to a number, or you could print it, right? So what you could do now is you could say print get difference of 5 and 2. So here we write print because the function itself doesn't do it. The function just returns a number, right? So hopefully that makes sense to you. So then if you could say print get difference of 5 and 2, and then that will go ahead and give us the 3 that we're looking for there. And then I guess we were still printing the 1, 6, 1, 6 from earlier. So let me go ahead and delete that and you get the 3 there. So hopefully that makes sense to you. And then what we can do is, but what if we, yeah, so then you can also do it with a variable, right? So what if we do g equals get difference of 10 and 4? So here basically g is initialized to 6, right? And then what if you say g times equals, what if you say g times equals get difference of g and 2? So what this is going to do is it's going to take the current value of g and multiply it by g minus 2, basically. So what it's going to do is basically it would say g is equal to 6 times 4, so now it's going to be 24. So now if you say print of g, then it would be able to do that. But here basically we basically assigned a variable to the result of this function. So hopefully you can understand the difference between calling a function that in and of itself prints something and calling a function that simply returns something, and then we could go ahead and print whatever it returns. So that's what happened with the get difference function. So hopefully that makes sense to you. And we've already talked about multiple concatenations. We've also talked about, just making sure that, we could also think about what about a list? So what about if we were talking about get sum of W, okay? And then what we're gonna do, so basically we want to take some input W and get the sum of the elements in it. So what you would do is you would say my sum equals 0. And then you could say for element in W, for each of the elements, I'm going to arbitrarily refer to all of the elements in W as element. And then for each of those, I'm just going to say, basically, I'm going to say my sum plus equals element. So it increments the current value of the sum with each next element, basically. And so now what you would do is you could either go ahead and print the sum using the function, or you could return it. So now let's just go ahead and say that this function is going to return the sum. So now what we can do is we can try it out with a sample list, right? So we could say sample list equals 3, 1.2, 2.5, right? And then you could say print get sum of sample list. So that's basically making a call to the function, and then you get the 6.7 there. But what if you said print get sum of 4, 5, 2 with these 3 different inputs? Well, first of all, this function doesn't accept 3 inputs. It only accepts 1. So that's one of the reasons why you'd have an issue with this code, why you get this runtime error. But what if you had only put in 1 value? What if you had only said get sum of 4? The problem is that you have to, basically what we said is that data types that you put into a function are arbitrary, unlike in Java, but the data types have to make sense within the context of the function here. So here we can only use a for loop on something called an iterable. And right now we know of a list, but we're also going to learn about a set, a dictionary, and a tuple. And so basically these are the only 4 data types you could pass into a function, where you're going to say for each of the elements in that input. So hopefully that makes sense to you. What if you had a Boolean? What if you had a Boolean, right? So you could basically, you could have another one. So you could say basically define is positive of t, right? And then you could just say return t greater than 0. So basically this function accepts a number, by, I guess by implication, right? By implication, because it's being compared, with another number, right? So you wouldn't really say, oh, is a string greater than 0? But you could see if a number is greater than 0. So now what you could do is you could say print is positive, and you could pass in a number. You could say print is positive of 5, right? And that would go ahead. And let's see, there was still an issue with the get sum. So let's remove that, and then we can go ahead and run it. And then we get the true there. So hopefully that makes sense to you, right? And then what if we said bool of is positive of 5, right? So we said that bool of anything besides 2 things is true. 0 and false, right? So then if you go ahead and say Boolean of a true, certainly that's true. But what if you say Boolean of not is positive of 5, then that would return, that would return false. What if you say Boolean, print of Boolean of not is positive of -5, that would return true. So hopefully that makes sense to you. What I wanted to talk about this video, hopefully you're getting more familiar with these functions and you can go ahead and call them. What I wanted to do is say that you can also have a nested function. So what if you say basically, you could say nested function of f and x, and then what this would do is you could say return f of x. So basically this would allow you to pass in a function as an input to another function, right? So now what you could do is you could say basically add them. What if you say add them of a and b, right? And so then you could say return of a plus b. So that's one example of a function. And then you could have another example of a function that would just basically return the product of 2 numbers. And so now you can go ahead and see what this would do. So if you say printed nested, if you say print nested function of add them, right, you can just go ahead and put in the function name, and then whatever let's see, whatever inputs you would want to have, right? So I guess you would have to have X and Y, right? Because if these are functions of two variables, then you need to pass in two variables to the original nested function. So what I'm trying to say is that this function accepts three inputs. One of them is itself a function. And so what this function does is it returns the result of that function which you passed into the function, calling X and Y, which are the second and third inputs of that big general grand function. And so we said these are two examples of functions that you could put in as an input to this nested function. So hopefully that makes sense, right? So if you say add them, you know, if you say nested function of add them with 2 and 3, what happens here? So we would have to close up that parentheses, and then we can go ahead and run it, and you would get 5. But then if you go ahead and say multiply them in here, then you could go ahead and run it, and you would get 6. So basically what I'm trying to say is that a function can be an input to another function, So hopefully that gives you an example of the architecture. And I wanted to talk about one more concept, but we'll go ahead and review this in the next video just so that you guys can see it one more time. But that's basically the example of what we have going on with that. What we can do is we can also talk about one more topic in this video with the 4 minutes that we have remaining. So that's called docstrings. So we said in a previous video, we can have a multiple line comment if we have 3 pairs of double quotations. So you could basically say this is a multiple line comment, right? And we said you could also print a multiple line string. The only difference is that you would say print of that, right? And then remember, we could have all those lines printed just one at a time. And that's, you know, so that's pretty easy. But this is a multiple line comment. But what we do is we say basically in Python, it is important that functions have important, clear, and useful documentation. Okay, documentation. So what we're going to do is that in future videos, we will see examples of standard Python functions and how they have detailed documentation and descriptions for how they work, And then the goal is for functions we write, we want to provide a description of how the methods work. So this is called docstrings. So it's important to provide docstrings. It's usually just good etiquette. So we will write a multiple line comment immediately under a function header to describe how the function works. So let me give you an example. What I'm going to do is I'm going to come up with a new function. So I'm going to say define print first value of s, right? And then I'm going to say basically print s of 0. So here the implication, if I'm using basically this index position thing, basically the assumption here is that s is some kind of iterable. So assumption s is an iterable. So for example, you know, we'll talk about different types of iterables, but you know, the only one that we know for now is a list, right? So basically what we do is we make a docstring. So you're going to go ahead and have these 3 pairs of quotations immediately under the function name. And then what you're going to do is you're going to say this function accepts an iterable s and prints the first value. That is the value at index position 0. And then that is basically an example of a docstring. And so now what happens, now this is one of the features of the integrated development environment. What do you think would happen if we hover over the print first value function? So we've seen examples of this, right? We've seen standard functions, right? If you go ahead and hover over print, I think I showed you before of how it gives you a description of the print function, right? Print is a function. So it says prints the values to a stream, right? And you can see different examples of that, right? What if you said list of range of 3, right? What if you wanted to see documentation for the list function? So that if you hover over list, it would say the constructor creates a new empty list, but the argument must be an iterable if specified. So basically it gives you basically a little bit of a description of what these functions do. So range, it says return an object that produces a sequence of integers from start to stop, inclusive and exclusive. And we sort of talked about what those means. But now if we go ahead and hover over the function that we wrote, print first value, it says this function accepts an iterable s and prints the first value. That is the value at index position 0. So our docstring is written immediately below the function header. And that's actually one distinction to be made between Java and Python. So we write docstrings, which are basically descriptions of what functions do immediately after the function header, so the title, right? This is unlike unlike in Java, okay? And then in this kind of formal documentation, we call that Java docs, okay, which are written immediately above a function header. So we're going to see a few more examples of that. So in the next video, we can go ahead and review nested functions as well as docstrings, and then we'll talk about new concepts. But there wasn't too much new content in this video. The takeaway is that basically functions can have comments, and this is how they're written. This would be considered good etiquette if you were writing code at a software engineering company. So from UMills03, thanks for watching, and please subscribe.